For this section, we're going to look at equations and problem solving. And a lot of times when you're in a math class, if you see the words problem solving or you see applications, it doesn't always, but it frequently means word problems, okay? So for this first example, we're just going to review the idea of direct translation. We talked about this in the last video. We're going to practice it some more, and then we'll get to the point where we look at what some people call story problems, the ones where you've got like some kind of real world situation going on. Okay, so for topic one, we're just going to review direct translation. Okay, so for our definition, we have that direct translation is the process of converting words to math. So you're going to take expression, or not, I don't want to say expressions. You're going to take phrases or sentences and convert them to algebraic expressions or equations. Okay, so part of that, let me plug my computer and it's about to die. There we go. Part of that is this goal of assigning a variable to what we don't know. So when you have these problems, a lot of times you, the mathematician, has to assign a variable or variables to some unknown quantity. So we will definitely be practicing that. Okay. Now I'm not going to go through this next table in its entirety. You can pause the video and kind of read through it. But this is a table that just gives common words and phrases that would indicate addition, subtraction, multiplication, division, and then equal sign or equality. Okay. So again, you don't have to memorize this table or anything like that, but just sort of familiarize yourself with it. Think about words and phrases that would indicate these different operations. Okay. Now we're going to do two examples in this video. The first one is we're going to take just basic phrases and we're going to convert them to algebraic expressions. And then we're going to, in example two, take phrases, sentences, and we're going to convert them to equations. So just really quickly before we start, an expression, go back here. Expressions are combinations of variables and constants. You could also have like coefficients. You could have your variable multiplied by some number, or you can have numbers all by themselves. So variables and constants along with operation symbols. So for us, operation symbols are plus, minus, multiply, divide. You could also have exponents potentially, okay? So in other words, expressions are the sum or difference of terms. So go back to the first section in this chapter, terms. They can be a constant by itself, a variable by itself, or a variable multiplied by some number. Okay. So that's what expressions are. Okay. Now, equations, what makes an equation is the fact that it's a statement that says two expressions are equal. Okay. So an equation is a mathematical statement that two expressions are equal. Okay, so you need to think equations and equal sign. So equations have an equal sign, expressions do not. Okay, so let's go down to example one. Again, for example one, the directions say translate each sentence into an expression. So there's not going to be an equal sign here. Okay, and we're going to let the variable x represent the unknown number. Okay, so for part A, it just says we want to find an expression that represents double a number. So double a number is two times something. Anytime you double something, you multiply it by two. So we're looking for two times some number. Well, we're going to let a number, let's highlight our unknown in like maybe blue. So we're going to let this number be our variable, okay? And in order to double it, we just want to multiply it by 2. And when you multiply a variable and a number, you just write them side by side. So we would write this as just 2x. That reads 2 times x, but you don't have to put a multiplication symbol in there, okay? So part B, we have -9 increased by a number, okay? Well, that's not too bad. We have our a number. All right, so we know we're starting with -9, and then we want to increase it. That means add some unknown number x. So we would just get negative 9 plus x. Okay? Now for part C, we have 18 minus a number. So this number, that's going to be our variable. And we want 18 minus a number. So 18 minus x. Okay, I want to say it's that simple, and there does come a point where this becomes really simple for a lot of us, especially these like really straightforward expressions, but just keep working at it, okay? For part D, it says 18 subtracted from a number. Now be really, really careful with this one. We have 18 subtracted from a number. And when you're dealing with subtraction, order really does matter. With addition and multiplication, we have this thing called the commutative property. And the commutative property allows us to change order of add-ins, that means things that are being added, or factors, things that are being multiplied. But with subtraction and division, order absolutely matters. So you can't write subtraction or division in any order. So in this case, we have 18 subtracted from a number. That means we're going to take this number, this unknown value x, and we're going to subtract 18 from that. So we would write this one x minus 18. So really pay attention to parts C and D. They're almost the same, but the subtleties in the wording mean a big difference algebraically. Okay? Now for part E, we have the quotient of a number and 6. So this a number, that's going to be our variable. And we want the quotient. And in the previous video, or I guess it was really the previous worksheet, I told you that in math, when you're doing like this direct translation stuff and you're getting to that point where algebra is involved, you don't use this division symbol. So don't use the traditional division symbol. When you get to the world of algebra, we don't use that symbol. Instead, we use fractions. So when you see the word quotient, think fractions now. So the quotient of a number and 6. Well, just like with subtraction, with a quotient, order matters. And so you do the order quite literally the way it's written. So we had a number written first, and then we had and 6 written second. So this is always going to be the first number divided by the second number. So we're going to write this as x divided by 6. Okay, so that would be our expression. The quotient of a number and 6 is basically a number divided by 6, but in fraction form. Okay, and then finally for example 1, part F, we have twice the sum of a number and 12. So we want twice an entire sum. And remember, a sum consists of 2 parts. So this means we're going to need 2 times something inside parentheses, okay? So we have twice the sum of a number and 12. So we need to kind of set the stage for this. Remember, a sum contains 2 parts, and we want 2 times a sum. So we want 2 times a sum. So for us, that's going to be 2 times the sum, that means add, of a number and 12. So just be really careful when it says 2 times a sum versus like 2 times a number. 2 times a number, you're only doubling the number. 2 times a sum, you're doubling the entire sum. Okay? So there you have it. That is direct translation, just creating little expressions. In the next example, still part of this video, we're going to translate sentences. And we've already done this. We did this in the previous worksheet. So hopefully this won't be too crazy for you. So example 2 says translate each sentence into an equation. We're going to again let x, we're again going to let x represent the unknown number, just like we did in the previous example. Okay? So we don't have to solve these. We're just practicing direct translation at this point. So for part A, it says we have the product of a number. We don't know what the number is, but that's going to be our variable. We have the product of a variable and 2 is 28. So we also need to figure out what our equals is. Well, 28, or our the product of a number and 2 is 28. So is going to be our equal sign here. Okay? So the product of a number and 2, that means multiply. So we want to take some number, x, and multiply it by 2. Now, the way it is written is like literally in order. So if you wrote this out kind of as you're reading it, you would write it as a number times 2. But in algebra, we would write the number first. And that's the cool thing. Remember, multiplication is commutative. That means you can change the order. So for us, we would want to write this as 2 times x. But the cool thing is in algebra, if you want to write 2 times a variable, you just write them side by side. You don't actually have to put a multiplication symbol in there. So we just want to write 2x. So even though it comes to us the product of a number, x, and 2, we're going to write it like this. So we're going to get 2x. And we know that is means equals, so 2x is 28. And that is our final expression, or our final equation rather. So the product of a number and 2x, is equals 28. Okay? Now for part B, it says the sum of a number and -4 yields 17. So we've got the sum of some unknown number and -4, and it's going to yield, which means equals 17. Okay. Now we have the sum of a number and -4. Sum means add. So we want to take whatever our number is and add it to -4. And that's going to yield, which means equals 17. All right. Next up for part C, we have 11. Be really careful with subtraction. 11 subtracted from a number is -15. So we want to take some number and from that subtract 11. So we're going to take our variable x and we're going to subtract 11 from that. Remember, subtraction order absolutely matters. So you have to really read for context clues here. So we want to take 11 and it's going to be subtracted from something else. So the thing it's being subtracted from comes first. Then we show the subtraction of 11. So x minus 11 is, that means equals, and we get -15. So that's it. Okay. Part D, we have 3 times the difference between a number and 9 is equal to -16. So we've got our number here, and we have the word is equal to, so that's going to be the actual equal sign. Okay. And be careful with this one. This one says we want 3 times the difference. Okay. If we have 3 times a difference, we want the entire difference to be inside parentheses. We want 3 times the whole difference, not just 3 times part of the difference, okay? So we're going to start here with parentheses, and then we want to put whatever our difference is inside the parentheses. So our difference is between a number and 9. So we're going to write that as just x minus 9, and then is equal to is going to be our equal sign, and this is all equal to -16. So once we're done with this section, really go back and look at the equations that we've built and see how they really do kind of come from those statements. So see the connections between the sentences and the equations. All right, part E. We have the quotient of double a number and 10 gives 14. Okay, so be especially careful with this one. We have a quotient. Okay, and remember when we have a quotient, think fractions, okay? Don't use the little division symbol, okay? So don't use the like stereotypical division symbol, okay? So we have the quotient of, well, we've got double a number, okay? And 10 gives 14. So how would you write double a number? Well, double a number is 2 times x, but we want the quotient of that and 10. So we get double a number divided by 10 gives, which means equals 14. So there's our equation. All right, last up, we have twice the sum of a number and 1 is the same as 3 times the difference of a number and 2. So we have this unknown number twice. We're going to use the same variable for each of these situations. And then we have is the same as, that's going to be our equals sign. Okay, so we want twice an entire sum. And if you want twice an entire sum or twice an entire difference, you need to put the sum or difference in parentheses. So we want 2 times the sum of a number and 1. We know that is the same as, so equals 3 times the difference. So we want 3 times an entire difference, so another set of parentheses. And we want the difference of a number and 2. So just remember, sum means add, difference means subtract, okay? So take some time with these, really read the statements, read those sentences and see how it translates to that equation. Read the equation, look at the equation, and really see how that translates back to that statement. Make sure you can build simple expressions or simple equations like we did here in example 1 and 2, okay? When we come back, we're going to look at the whole problem-solving situation where we have like some real-world scenario where it's kind of like some people will call them story problems. So it's not just these generic statements like what we did in examples 1 and 2, but you're going to have some kind of like real world situation happening. Okay.